It'll be easier to find the volume of a solid by using this method instead of the previous method. So let's take a look at this method. The idea behind it is that you're going to rotate this area around some axis, and then you'll be able to create a cylinder, and you want to subtract the inner cylinder. After doing some algebra, it'll come down to this formula here, where 2 pi x represents the circumference of this cylinder. If you were to cut it open and spread it out, it would create this like rectangular prism. This is the length, which is the circumference of the cylinder, and then you have the thickness and then the height. And so that's basically what we're going to be doing in order to figure out the volume. All right, so here it is. Circumference times height times thickness will give you the volume. So let's look at the first example. Find the volume of the solid obtained by rotating about the y-axis, and you got these functions that are bounding the region. So let's graph those. So y equals x cubed, that is our cubic function that looks something like that. Y equals 0 is this horizontal line that goes that way. X equals 1 is this horizontal line that goes this way. And then x equals 2 is also a vertical line, that goes that way. So this is 1, this is 2. And if you rotate this about the y-axis, it's going to create another little region that looks something like this on the opposite side. And then here you have your cylinder. You can draw it if you'd like. And here's the top of the cylinder. Here's the bottom of the cylinder. All right, and so the volume is going to equal to, here's our formula. We can take out the 2 pi since that's a constant. I'll do that. 2 pi. X is the radius from here to here. That's x. Times the function. Well, the function is the top minus the bottom, but the bottom is just 0, so it's just going to be the top function, which is x cubed. Well, this is all with respect to x. And our limits are going from 1 to 2. As you can see from here to here, that's our limit, 1 to 2. So our lower limit is 1, our upper limit is 2. So this is going to become 2 pi integral 1 to 2 x to the 4th with respect to x. So this is going to be 1/5 x to the 5th antiderivative. And we have 2 pi, the constant, going from 1 to 2. So it's going to be 2 pi times, that's going to be 32 over 5 minus 1/5, which is, that's going to be 31 times 2 is 62/5 pi. And that is our final answer. So it's up to you to determine which method it makes more sense for each specific problem that you're working on, whether it's the disc or the washer or the cylindrical shell method. Sometimes both of them will apply, and it's just a matter of your preference. All right, let's look at number 7. This one should be a little bit more challenging because we're rotating about a different axis instead of the x or the y-axis. So this is going to be a little bit harder. So let's graph the functions. You can use Desmos.com again, or your graphing calculator to graph if you'd like. This is a parabola that's opening downward. It's going to look something like this. And then y equals 3 is going to be 1, 2, 3, a horizontal line that goes this way. All right, and to find the points of intersection, you're going to need to do that. So set these two functions equal to each other. If you bring all the terms to one side, you're going to get this quadratic, which is going to factor into, and the points of intersection are 1 and 3. So 1 and 3. Okay, and we're rotating about the x equals 1 line, so that's going to be this axis of rotation. All right, so you can imagine this is going to look something like that. And our cylinder will be like here and here. You can draw that if you'd like. So once again, the volume is going to be 2 pi on the outside, x. This is the part that's a little bit tricky. Your radius, x represents your radius, but your radius would not be x because this entire thing would be x. But that's clearly not the radius. The radius is only going from here to here, as you can see. I would only focus on the original graph. If you focus on the other one, it gets a little confusing. So just focus on the original sketch, which was just the right side. And you're looking for this radius of this cylinder. So from here to here is x, and from here to here is 1. So to get this little region, or sorry, length, that's going to be x minus 1. So once again, this is x, this is 1. In order to get the radius, that's x minus 1. So that is our radius. And then the function height would be that minus that. So the upside down parabola minus 3. This minus this. So it's going to be 4x minus x squared minus 3, all with respect to x. All right, so now you have to do some algebra here. So if you do some algebra, and we know that we're going from 1 to 3. If you do some algebra, I'm going to save us a little bit of time since I've already done all this. It's going to be 4x squared minus x cubed minus 3x minus 4x plus x squared plus 3. All right, simplifying that is going to give us, I'm just going to simplify this, and it's going to become negative x cubed plus 5x squared minus 7x plus 3. All right, so I'm just going to kind of draw a line through that and show that we've simplified it there. And now if you take the antiderivative, you should get negative 1/4 x to the 4th plus 5/3 x cubed minus 7/2 x squared plus 3x. And we're going from 1 to 3. And don't forget that we still have the 2 pi out in the front. So now if you plug in 3 and then minus 1, I'm going to save us the time, but you can obviously use your calculator to do all this computation. You should end up with 8/3 pi as our final answer. All right. So once again, the tricky part, at least for me, is the radius. And the radius is this distance. So once again, from the x-axis all the way to that rectangle, that's x. And this is 1, so x minus 1 gives you the radius. All right, the last problem for this section is going to be a volume of the solid obtained by rotating about the x-axis this time. So let's graph these functions once again to see what the bounded region looks like. Radical x looks like this. 0, x equals 0 is just your vertical line there. And y equals 2 would be a horizontal line right there. Okay, so this is a region that we're rotating, and we're going to rotate that about the x-axis this time. So if you do that, it's going to give us this region down below here. And now, as you can see, our rectangles are going to be horizontal instead of vertical, which means we're going to be integrating with respect to y instead of x. There's our cylinder. It's sideways. So our volume is going to be 2 pi, and we are integrating from 0 to 2. All right, so 0 to 2. We're integrating from vertically as opposed to horizontally. So that's why it's going to be with respect to y. Okay, and the radius is the distance from here to here, which is just y. The radius is just y in this case, because we're rotating about the x-axis. So there's no translation, so that makes it easier. All right, and then the height is going to be the top function minus the bottom function, but the bottom function is just 0, so it's just this top function, which is this, which is radical x. But we need to solve for x, so you can't mismatch variables. You couldn't put radical x because then we're integrating with respect to y, so we want to solve for x in this case, which is pretty simple. X is just y squared, so that becomes y squared. All right, this is all with respect to y, so that is going to be 2 pi 0 to 2 y cubed with respect to y. That's going to be 2 pi 1/4 y to the 4th, 0 to 2. That's going to be 2 pi 16 halves. No, 16 fourths is 4. The 0 we don't even have to plug in. That is our final answer, a pi. And that concludes